We have up here showing the profit in Danish kroner per cow, and here 600 Danish kroner is approximately 1,600 manads. We have analyzed, or someone have analyzed, the profit in different size groups, from 0 to 100 cows, for farms with between 100 and 200 cows, and so on, different sizes. And for each of the size groups, they have put the farms in 3 groups. Those with the highest profit per cow, that's the blue one. Those with the third number of farms with the highest profit, the middle group, and the third share of farms with the lowest profit per cow. And totally, this is statistics on 1,400 farms, and the smallest groups here, one of the bars here is the figure for average of 90 farms. So it's quite a number of farms. And what we see here, especially for the smallholders, it is that there's a big variation in profit per cow. The best of those farms, the best measured in profit, they make something like 3,200 manads per cow in profit. Those who are doing it bad in average, they are making very, very little. And for sure of them also make losses. So the question is, again, if you look at the average figures for those groups here, you might get the impression that there is some economy of scale and the biggest farms make a lot of profit. But if you look into the different size groups, you realize that the variation is very big. And that's, of course, an issue for Ministry of Economy, for Ministry of Agriculture. It is to ask, are these figures we get as average for a group, are these describing the reality in the real world, or is there a big variation hidden behind? So that was the other issue related to statistical analysis. It is variation in real life. Is it covered? Is it described by the figures we get? And when we make forecasts, for sure we also have a lot of uncertainty. We are making forecasts for different indicators when we are evaluating the policy, but how good are these forecasts? Yeah, okay, it could be some issue related to methodology of collecting data or databases we are using. Do they reflect the reality? Then we know that there are some statistical uncertainty that partly depends on the variation in the real world. We saw that on the profit on the cattle, big variation or not so big variation. Partly also depend on the size of the sample. And then, of course, our processing of data. Is our models good enough? We cannot say if models are good enough. We only have to check that afterwards. But for sure, we can evaluate and estimate the statistical uncertainty. And then it's a question on how to cope with this uncertainty. In statistics, in general, we are coping with the uncertainty in the way that we either calculate confidence intervals. A confidence interval in statistics, it is the interval with minimum and maximum value where we say there is 95, 99% of probability that the figures are in this interval. For example, if we estimate the total production of a farm, total production of tomatoes on a farm, we could say it's 95% of probability that the production will be between 135 and 150 tons. Okay, then we know which range we can expect the production to be. So that's one way of coping with uncertainty. Another way of coping with uncertainty, it is to get the significance. And significance, it is to say, is a calculated figure. Is it for sure showing something different, or is it not showing something different? And an example of this could be to say the production of tomatoes will increase compared with last year, and the risk for making mistakes, the risk for making mistakes is, for example, maximum 5%. So we are saying, what are the risks for making mistakes with our conclusions here? I'll drop the next one. Yes. Let me show how we have coped with this in some examples in Denmark. Our Danish Institute for Food and Resource Economy, it can be compared with the Agricultural Research Center. They have made some forecasts on how the agricultural sector will look for the next 10 years. So how will the agricultural sector look in 2030? And here, for example, they're saying that the number of cows will increase from 584 cows in 2020 until 629 cows in 2030. And it will be 600 cows in the middle here. For sure, it looks like the number of cows are increasing in Denmark, for sure. But then this researcher, he made an estimate on the uncertainty. He said, what is the confidence interval for 2030? And the number of cows we are saying is 629,000 cows in 2030. It will 90% be between 527 and 731. Very large interval. So what he's saying indeed, it is, we cannot say that the number of cows will increase with certainty because there's so big uncertainty on the figures we are calculating that it could be whatever figure in this interval. That is quite interesting. Regarding the milk yield that was calculated as well, increasing from 9,500 over 10,100 to 10,700 in 2030. Also look like the milk yield is increasing. And when he calculates the uncertainty, he say, okay, 90% for sure, the figure in 2030 will be between those two. And what he's saying it is, the baseline, the yield in 2020 is not in this interval. So he concludes the milk yield will for sure increase. There are no problems in that. So that's one way of showing uncertainty in our forecast. It is to calculate these confidence intervals. Another example, it is use of antibiotic. The pig production in Denmark is quite big, and they're using a lot of antibiotics in the sector. We see the same in the poultry sector as well. And our problem it is we are afraid of that there will be bacteria that are immune for antibiotics, and that will affect the human health. So politicians, they wanted to reduce the use of antibiotic. What they did in Denmark, it was on this analysis, our research institute, it was they analyzed two databases, the FADN databases with the economy, with the database of veterinarian, where they see on the use of antibiotics, how much it is, and then they made some econometric analysis of the use of antibiotics. And what was interesting there, it was that they calculated what is the effect of changing the quantity of antibiotics used by 1% on the value of the production, the turnover, and the costs of the farm. And figures here might not be so interesting, but what is interesting, it is that they introduced the level of significance, saying if they put 1 star after a figure, it shows that there are 5% risk that the figure is not significant. 2 stars, it is that there's only 1% risk. And 3 stars, it is that there is 0.1% risk that the figure is significant. And again, what they did then, put the number of stars behind, so we can see how significant are these. What are the risks of that the figures, they are mistaken. Let's then go to see how data are presented in different analyses. And what we see in EU at the moment, it is that we go from those huge tables with a lot of figures, to a lot of ciphers, yes, just to some illustrations, to some pies, to some charts showing the analysis. So more visual presentation. We see that it's possible to create reports online. We see it's possible to download figures from different statistics to your reports. And we see that it's possible to continue to work with these downloaded figures on your own computer to continue your analysis. I saw statistical office, State Statistical Committee here in Azerbaijan. You are presenting a lot of figures on agriculture in Excel tables. That's very good, because then the users of your statistics, they can take these Excel tables, they can continue analyzing, working, making their own figures on it. So you are also going in this direction here. I have seen from Agricultural Research Institute that you make several analysis presentations where you have all these illustrations curves, graphics, pies, also going in that direction. So you're already doing a lot of that here. Time is running, so I'll do it a bit fast, just saying that in EU, the European Commission is doing the same. For example, DG Agri for GG for Agriculture and Rural Development, it's Director General for Agriculture and Rural Development. They present the FADN data now on their webpage, so you there can decide the table you want to have. You can decide which areas or which countries you want to have it for, what type of analysis, what countries, what years. So it's possible there to define your own tables. If you go to Eurostat, you have the same situation, that you can choose which indicators you want to have shown. You can choose which countries you want to have it shown for. You will see you can choose between 32 countries. That's a little more than we have in the EU. But it's also because they have data for Iceland, Norway, Montenegro, and so on. And you can choose the year you want to have these data from, so that's also a possibility. Statistic Denmark also have a database from where you can take figures. And this database here, it is again for the FDMS data. You can choose between 33 type of farms, horticulture, cattle, and so on, and how specialized they should be. You can choose the indicators you want to have shown. In reality, there are 244 indicators you can choose between, and you can choose the year. And this means, again, you can make your own table. You can have it in Excel, just like we have it from the statistical committee. And you also can choose between 10 different types of graphics. Where you can get the figure shown. It can be bars, it can be curves, it can be pies, it can be, a lot of things. When I now look at the situation in Denmark, I'll say, what are the areas that are in focus now in Denmark and in other countries? And I see that now the focus is especially on information department, where reports are looked at by some professionals who look into the layout to see, can we improve the layout? Can we put in some graphics that make it better? They look at the content, especially the summaries, some journalists, to see, can we make the language a bit more user-friendly? They look into the conclusions. Can we make them more clear? And they look into IT, as we just saw about building your own reports, and how to use the technology. Then quality control has also become quite interesting in Denmark now. For all reports made by our research institute, they are reviewed by colleagues to assure that the quality is okay. Also, Statistic Denmark have now review of all analyses, all statistics they're making, just to be 100% sure that there are no mistakes in the figures. And even if they're doing so, there are mistakes, of course, and they realize and they have to go back and they have to change. We still have few issues to solve. One of them it is that in some of our analyses we use very specific terms that are not understandable by many persons. For example, economic size. We use it in FADN. And what would it say that a farm has an economic size of 15,000 euro? No one will understand that. So what we often have done instead, it is to transfer these terms into number of animals, number of hectares. So if we say this is figures for a group of farms with 50 cows and 45 hectares, it's understandable. Everyone can associate with that. We also have the term livestock units that are used a lot, also not so understandable. Then we have the professional language. Sometimes researchers are very, very, very good in making their researches, but of course they also have some very specific language, and it also might be difficult to understand. And also sometimes the calculations are not fully understandable. In 2002, the European Council had a meeting in Barcelona, and there they decided that as a target for all EU, 3% of the gross domestic product should be used for research and development. That was the target. And it was also said that 1% of these 3%, 1% should be public funding, the last 2% should be from the industry, and the industry, it is of course the private sector. We have this, I think most of the EU countries, they now have reached this target. 3% of the gross domestic product is used for research. And this of course gives some challenges for the researchers. First of all, a large part of the funding, it is private funding. And that might not always be easy to handle, that you are sometimes making research for companies, after our lobby organizations, and afterwards you make some research for the government. This might also put you into some situations where there's a conflict of interest. And some of the Danish research institutes, they have now made it as an obligation for all researchers to declare their conflict of interest. Those of you who are cooperating with international researchers, you might also face this, that some of those you work with from international research institutes, they could have some conflicts of interest. Another issue that's quite difficult to handle, it is that the users of the informations, they also have some conflicts. For example, there are some very strong lobby organizations on environment that might have another opinion than the government or the Ministry of Agriculture. So it doesn't matter how good your results are and what it shows. If they are not satisfied with the results, they will criticize you. And then, of course, we also can talk about that there's a huge impact for farmers and other stakeholders on different issues. One of the examples of problems we have had in Denmark, it is the city I'm coming from, Aarhus. It's the second largest city in Denmark. We have a professor there who suddenly came out with some research showing that there was a bigger impact on climate change from use of beer, coffee and sweets in Denmark than the production of beef meat. And that was quite surprising. Afterwards, we found out that this research, it was funded by the Agricultural and Food Council. This is the lobby organization for farmers. And for sure, this researcher now has huge problems also in making research for the government, because they do not trust him any longer. I asked in the beginning, does the Danish FADN give value for money? And yes, we have to say, what are the value for money we get? First, the farmers who are participating in the FADN. They are recording all their activities, they are recording their cost, their income, so they get better knowledge on their production. They also get feedback so they can make benchmarks of their own production compared with others, and they can see where can we improve, where can we do it better. Then it also will give us better results for other farmers, those who are not participating, because advisors, especially agricultural advisors and farmers, they get knowledge from the FADN, they get analyses they can trust on, and they'll be better in advising other farmers. Banks and other businesses in the agricultural sector, they can make better assessments of their risk, their potential business, and so on, and hereby also increase their income. And then, of course, ministry and government can make much better policies. So therefore, we think that this €500,000 that are used for the Danish FADN, it is okay, because the value we get totally back from this is much more. Then let's go to the conclusions. What are my recommendations? And you are coming from different institutions, you have different interests in this. But I would say, first of all, regarding the data collection, think of if you can combine data from different databases to get analyses that are going across the agricultural sector, covering more. As for example, the analysis of wetland in Denmark, where different databases were used, the analysis of use of antibiotics, where different databases were used. Try to use administrative data that are already collected by the administration, because it's much easier to use that than go out and make your own survey and collect data. And be aware of if there are standard calculations that has to be reviewed, so you will not end up with the situation as Statistic Denmark saying each farm family will use 10 liters of milk per day. In analyzing the data, I would say also evaluate the results. There are a lot of statistical ways of analyzing, but have them reviewed by colleagues and consider if the variation in real world is reflected in the analysis. As we saw the profit per cow for some of the farms that could vary between 3,200 manats and 0, and these data were reflected in one figure, an average. And finally, when you get results of when you get results of analysis, evaluate the uncertainty. Ask, are these figures significant? Get an evaluation of that. Ask, what are the confidence intervals, if this is what you need. And then, in the presentation of results, please foresee that there might be very, very critical remarks, because some of the readers might not accept the result, even if it's real. And some readers will ask if the researchers are partial or not. That might also be a problem. And finally, be aware of that many of the farmers and the politicians, they are not experts in statistical models and methods. They are not experts in how to understand all the different issues. So try to see if it's possible to make the results more understandable. After this presentation, we'll have a coffee break. And some of you who are very interested in going more detailed into the technical analysis of econometrics and more detail into analysis of the FDMS data will be invited to follow-up trainings that will take place in later this year or maybe beginning of next year, but we hope it will be later this year. So, I think coffee is more in demand than questions. So let's take 20 minutes coffee break, and then come back here and discuss a little. So, hello.